Thank you for joining this lesson. We're going to discuss statistics 1. We are given a question here which says that the table below shows the marks scored by 80 students in a mathematics test. Then we have the marks X. Now the classes are given here. The first class is from 10 to 15 and including 15. Then from 15 to 20. Then from 20 up to and including 35. Then from 35 up to and including 45. Then from 45 to and including 60. Then from 60 to 65. That is the marks scored. Those are the classes. When you study the type of classes, you discover that this is continuous data. This is continuous data. Then the frequencies are given 3, 5, 30, 25, 15, and 2 respectively. We are told to draw a histogram to represent the data. So I would like us to draw the histogram to represent this data. But as we can see, these classes are not having equal widths. The class intervals are not the same. Therefore, because the class intervals are not the same, remember for a normal histogram where class widths are uniform, we could have plotted frequencies against the class limits. But now that the class intervals are not the same, then we use what we call frequency density. Frequency density. So I'm going to have frequency density, which is usually calculated using each frequency divided by the class width. Each frequency out of class width. Therefore, I'm going to have that row now, whereby I will fill the respective frequency densities. I will start with a frequency of 3, and I divide with a class width of 5. This gives me 0.6. The next is going to be a class interval of 5. So that will divide 5. So 5 divided by 5. This gives us 1. The next is going to be 30 divided by the class width here is going to be 15. So 30 out of 15. This gives us 2. The next is going to be a frequency of 25 divided by a class width of 10 from 35 to 45. So dividing by 10, this gives us exactly 2.5. 2.5. The next is going to be 15 as the frequency. Divide by, we got from 45 to 60. This gives us exactly 15. So it is 15 out of 15. And I'm getting a 1. The next will be 2. A frequency of 2 divided by a class width of 5. That is 5. So 0.4. 0.4. Therefore, I'm having now the frequency densities. I'm having the frequency densities. Therefore, now I'm going to plot frequency densities against the limits. Frequency densities against the limits. So, such a histogram whereby class widths are not the same, we plot frequency density against the limits or the boundaries. Yeah, actually the boundaries against the class boundaries. Therefore, I'm going to begin with the frequency densities on these axes. They should be on the vertical axis. The frequency density should be on the vertical axis. Then now on the other side, I will have the marks. I will have the marks on this axis. So for this axis, the x-axis whereby I'm going to have the marks, I'm going to ensure that I begin with the first lower boundary, which is 10. Then I will go to 15. So I have 10. Then I will go to 15. then I'll go to 20 according to these intervals, then I'll go to 25, I'll go to 30, 35, 40, 45, 50, 55, this will be 60, 65, which I think is the last class boundary. 65 is the last class boundary. Then now for the frequency densities, I'm having from 0.4 all the way to 2.5. Therefore, I can use intervals of a 0.5. Yeah, 0.5. Therefore, I'm going to have 0.5, 1.0, then 1.5, 2.0, then I'll have 2.5, 3.0, yeah, 3.0. Therefore, now I'm having my frequency densities on this side. Frequency density, which are given by frequencies out of the class widths. So frequency densities are plotted on that side. Therefore, now I can come up with a graph. The first class is from 10 to 15. Then I'm having a frequency density of 0.6. So 0.6, if this is 0.5, this is going to be 0.6. Therefore, that class is going to have a height of 0.6. 0.6. The next class is running from 15 to 20 with a height of exactly 1. The frequency density is 1. Therefore, from 15 to 20 and a height of 1. The heights of these bars are going to be the frequency densities. The other one is exactly 2, but it is from 20 to 35. So from 20 to 35, and the height is 2. The height is 2. Exactly 2 is here. So the height is the frequency density, which is 2 in this case. Therefore, that is how the class is going to be. That is how the class is going to be. The next class is from 35 to 45. 35 to 45 with a height of 2.5. With a height of 2.5. So all the way to 2.5. From 30 to 45. So this is where the class will reach. Remember to subscribe to this channel. The next is from 45 to 60. So from 45 to 60 all the way to here. 45 to 60, the height is 1. The frequency density is 1. Therefore, frequency density of 1, the class will reach here. The class will reach there. Then finally, we are having a class from 60 to 65 and a frequency density of 0.4. So 0.4 is somewhere below 0.5. Yeah, 0.5 at that point. Then the class is here. Yes. So this is our histogram, whereby we have plotted frequency densities against the class boundaries, and we've come up with the graph. Now it's upon us now to use the histogram to estimate the median. Something we are supposed to know is that the area of this bar is going to give us what we're calling frequency F, or rather the number of students in that class. For example, the frequency density of 0.6 and the width of 5. 0.6 and the width of 5 will give us 3. That is the number of students, or rather that is the frequency for the first class. Therefore, for the first class, we are having 3 students. we are having 3 students, like that. Therefore, every area for each bar will give us the frequency, because actually we got the frequency density by dividing frequency by the class width, which means when we multiply class width times frequency density, we will get the frequencies, the respective frequencies. Therefore, we want median in this case. And how to get median is that already we've been told that this is data for 80 students. But anyway, we can still get what we call cumulative frequencies to confirm. So we can have cumulative frequencies to confirm. We start with 3. We add 5, we get 8. We add 30, we get 38. We add 25, this gives us exactly 63. Then we add 15 to 78. Then we add 2, this gives us 80. Exactly 80. So those are the cumulative frequencies. That means the median student is the 40th student. The 40th student. Therefore, we want to get the max of the 40th student. The max of the 40th student. And the max for the first 3 students are, the highest is 15. The max for the next, now we go to the next class, whereby we will have a height of 1 and a width of 5, which means the number of students here are 5. Then the next, we're going to have a height of 2 and a width of, this is 15, from 20 to 35. So 2 by 15, this gives us 30. So we have 30 students lying here. Then now, in this other class now, we don't want all the students lying in this class. We just want the number of students that when we add to the numbers we've already counted, we will get the 40th student, so that we may read the mark here for the 40th student. Therefore, this is 3, 5, and 30, giving us 3 plus 5, 8, 8 plus 30, 38. So we only want the area that will give us the 2 remaining students, so that we may get 40. The 2 remaining students. We have 38 so far. 3, 5, and 30, 38. We want only 2 students. That means with a fixed height of 2.5, we can know the amount of width here we will move, so that we may have the 40th student accommodated. Therefore, we will say we need only 2 students, frequency of 2, because I've said the areas are giving us frequencies. Now that this width and this height are giving us 30 students, we want the other 2 students which are in this class. We want the width that will accommodate them, because the area is 2 students. The area is the number of students, 2 students, times we need this one to be gotten from a height of 2.5 and a known width. So to get this width, we will need to divide 2 by 2.5. 2 divided by 2.5. This gives us exactly 0.8. Therefore, when we add 0.8 from 35, we will get our median mark, because that area will be representing 40 students. Therefore, the area that represents 40 students is when we add 0.8 to 35, and we can do that line. So the line is here. This line shows us 0.8 from 35. That means when we had 0.8 now from 35, the median itself is going to be 35.8. 35.8 marks. This will be the median mark, because now it is the mark which exactly shows 40 students, the first 40 students. We have 3, 8, then 38 because of this 30. Then now we add 2 students, which we had to get the width. The height is already fixed at 2.5. Therefore, we had to calculate the width that we require. And the width of 0.8, when added to the limit here, which is 35, we are getting 35.8. So that is how we get median using the histogram. We can confirm the value of this median using the formula for median. So when we use the formula for median, we know that median is given by lower class boundary plus n out of 2 minus cumulative frequency before the median class divided by frequency of the median class, then everything multiplied by the width, the class width. Therefore, in the substitution of this formula, I will start with the lower boundary of the median class. Now, the median class is the class that accommodates the median. The class which accommodates the 40th student is going to be, when we count using the frequency, the cumulative frequencies, we discover that up to this we have not reached the 40th student. So this is the class having the 40th student, and it becomes our median class. Therefore, the lower class boundary in this case is going to be 35. In continuous data, the limits are also the boundaries. That is something to be known. In continuous data, the class limits are also the class boundaries. Therefore, the class limit here is 35, which also becomes our lower class boundary, 35. Therefore, we use 35. Then we add n out of 2 means 80 out of 2 minus cumulative frequency just before this class, and we have a 38 there, divide by frequency of this class, which is going to be 25. Then we multiply with the class width of the median class. The class width is going to be, it is from 35 to 45, therefore 10. Exactly 10. Therefore, now we can compute 40 minus 38. 40 minus 38, then we divide by 25, then we multiply by 10. This gives us 0.8. The whole of this gives us 0.8, and when we add it to 35, we get 35.8 max. So the median mark is 35.8. We have confirmed the same figure we've gotten from the histogram with the figure we are getting from the calculation using the formula. Thank you for following. Subscribe and share.